The Sun's evolution is a fascinating and complex process, spanning billions of years. Approximately 4.6 billion years ago, the Sun began its life within a vast, cold cloud of gas and dust known as a molecular cloud. This cloud contained remnants of previous generations of stars, enriched with elements heavier than hydrogen and helium. A disturbance, perhaps a nearby supernova, triggered the cloud's gravitational collapse. As the cloud collapsed, it began to spin and flatten into a disk called the solar nebula. Most of the mass concentrated at the center, forming a hot, dense protostar. The increasing pressure and temperature in the core eventually ignited nuclear fusion. The Sun entered its main sequence phase, characterized by the fusion of hydrogen into helium in its core. This process releases tremendous amounts of energy, which radiates outward as sunlight and heat. The Sun is currently a G-type main sequence star, also known as a yellow dwarf. It has been in this stable phase for about 4.6 billion years and is expected to remain so for roughly another 5 billion years. During the main sequence, the Sun's luminosity gradually increases as the helium content in its core rises. This means the Sun is slowly getting brighter over time. After billions of years, the Sun will exhaust the hydrogen in its core. The core will contract, while the outer layers expand and cool. The Sun will become a red giant, significantly larger and cooler than its current state. Its outer layers will expand to potentially engulf Mercury and Venus, and possibly Earth. Eventually, the core will become hot and dense enough to ignite helium fusion, converting helium into carbon and oxygen. This helium flash will cause the Sun to shrink and become hotter, but it will remain a red giant. After the helium in the core is exhausted, the Sun will become unstable and pulsate. Its outer layers will be ejected into space, forming a glowing shell of gas and dust known as a planetary nebula. The remaining core, composed mainly of carbon and oxygen, will contract into a dense, hot object called a white dwarf. A white dwarf no longer generates energy through fusion. It simply radiates its residual heat into space. Over an extremely long period, potentially trillions of years, a white dwarf is theorized to cool down and become a cold, dark object called a black dwarf. However, the universe is not yet old enough for any black dwarfs to have formed. The Sun's evolution is driven by the balance between gravity and nuclear fusion. The Sun's life cycle will have profound effects on the solar system, particularly Earth. The Sun's brightness increases roughly 10% every billion years. The Sun's light, although called a yellow dwarf, is actually white. If you like our video, please subscribe to my channel, like, share and comment for informative videos.